A Ferris wheel is 20 meters in diameter and boarded from a platform 32 meters above the ground. The 6 o'clock position on the Ferris wheel is level with the boarding platform. The wheel completes one full revolution in 6 minutes. How much of the ride in minutes and seconds is spent higher than 13 minutes above the ground? We can assume that the Ferris wheel is a circle. In this case, the diameter of the circle is 20 meters from the highest to the lowest. The 6 o'clock position is at the bottom, 3 o'clock, 6 o'clock, and it's level with the boarding platform, and we were told that the boarding platform is 2 meters above the ground, and so the wheel does not touch the ground. This distance is 2 meters. From the center of this circle to the ground level, that distance is the radius of 10 meters because the diameter is 20. Thus, from the center to the ground level, that distance is 12 meters. How much of the ride in minutes and seconds is spent higher than 13 meters above the ground? The center of the wheel is 12 meters above the ground, so 13 meters is a little bit, or in this case exactly 1 meters above the center. To answer this question, we first need to find the model that represents the height of the motion at any time t. The generic sinusoidal models is of the form a sine of omega t minus any horizontal shift plus the vertical shift, or y equals a cosine of omega t minus c plus b. We know that there is a vertical shift this time because the midline or the middle is no longer at y equals 0. In fact, the height of any position on the wheel is at least 2 meters from the ground level, which is assumed to be y equals 0. To determine which model to use for convenience, it doesn't really matter which model, but if we use one versus the other, we might not to perform the horizontal shift. We will map out the position of the motion. If we board the wheel, then it is assumed that time is 0. When time is 0, our position is 2 meters above the ground. The wheel completes one cycle every 6 minutes, meaning after 6 minutes, we will end up at the same height, which is 2 meters above the ground. We start at the 6 o'clock position, which is 2 meters above the ground. Going counterclockwise, reach the maximum height, and then come back. The maximum height is not 20, but 22, because the diameter is 20 and the bottom is 2 meters above the ground. And so, half of the revolution is 3 minutes after. We will reach the height of 22, not 20 meters. The midline, or the middle of the minimum and the maximum, is therefore 12. It looks like the motion starts from low to the middle, and then high, and then back to the middle, and then back to low. This is a cosine model. It is actually the negative of the cosine model because cosine starts from high, middle, low, and then middle, and then high. The amplitude is the distance from the middle to the maximum. In this case, the middle is called the midline. To the maximum, that distance is 22 minus 12, so the amplitude is 10 in this case. And so the absolute value of A is 10. But because this is the flip of the cosine function, A is negative 10. Even though the amplitude is the positive number, in this case, we would use A equals negative 10. Omega is always 2 pi over the period. In this case, the period is 6, so this is 2 pi over 6, or simply pi over 3. The midline is the b value in the equation or the formula. The midline is 12 in this case. Another way to find the midline b is that we take the maximum plus the minimum and then divide it by 2. There's no need to do that if we have a visual graph or image in front of us. The maximum is 22, the minimum is 2 divided by 2, which is 24 divided by 2, or 12, as expected. So far, we come up with the model y equals a, which is negative 10 cosine omega is pi over 3, and then we would have a t minus c plus b is 12. But what is c? What is the horizontal shift? If we will use cosine, we do not have to perform the horizontal shift at all, because cosine starts from high to low, but we use a negative already, and so we just simply flip it down. And so t minus c is simply t. The model that we're looking for is y equals negative 10 cosine of pi over 3t plus 12. Always check to see if the model fits the situation. How do we know? If we plugged in 0, when time is 0, we expect the height to be 2. And so this is negative 10 cosine of t is 0, pi over 3 times 0 plus 12. This is negative 10 cosine of 0 is 1. And then negative 10 plus 12 is positive 2. If we plugged in 3, which is half of the complete revolution, we expect the height to be 22. Negative 10 cosine of pi over 3 times t is 3 plus 12. This is negative 10. Cosine of pi is negative 1 plus 12. Negative 10 times negative 1 is positive 10 plus 12 is 22. And so this model works. Now y represents the height at any time t after taking off, and we want this height to be higher than 13. And so we set negative 10 cosine of pi over 3t plus 12 greater than or equal to 13. We can then use a graphing calculator to graph the left-hand side and the right-hand side. There are two curves. The first is a sinusoidal, and the second one is just simply a horizontal line. We simply pick the interval between 0 to 6, where the first curve is above the second curve. If you are ambitious, you can isolate t in this case, now that we know the inverse trigonometric function. To isolate t, we would first subtract 12 both sides of the equation to get negative 10 cosine of pi over 3t greater than or equal to 1. 13 minus 12 is 1. And then cosine of pi over 3t equals negative 1 over 10. This should be greater than or equals. And then to get to t, we would have to take the cosine inverse both sides of the equation to get cosine inverse of negative 1 over 10. T is therefore 3 over pi cosine inverse of negative 1 over 10. Regardless, we will need to use a calculator in this case. Plug this into a calculator. We will get t approximately 1.6. This is 1.6 minutes after. If we were to go counterclockwise, we will hit the height of 13 meters after 1.6 seconds. We then stay above 13 meters height and then descend below 13 meters. And so the first time it was 1.6 minutes. What about the second time here? We can use symmetry to determine that second time. If the first time is 1.6, from 0 to 1.6 is the same distance from 6 to whatever this unknown times is. We just simply go back 1.6 minutes. If we take 6 minus 1.6, we will get 4.4 minutes. And so we will stay above 13 meters in the time interval 1.6 to 4.4 minutes. We will stay above 13 meters for roughly 2.8 minutes. And this 2.8 minutes is 2 minutes and 0.8 of 60 seconds. And 0.8 of 60 seconds is 48 seconds. And so the answer is 2 minutes and 48 seconds.